Welcome back, and in this this video we're going to be looking at the 2025 graphics paper, question 5. Okay, so it was the final question on this exam. So shown below is an incomplete logo for a bird watching location on a campsite. Complete the logo by constructing an axial symmetry on the line LL1. So we've got our axis of symmetry. All our points are going to need to travel through 90 degrees to the axis, and it will be the same distance on either side. So let's travel, have all the points projected through at 90 degrees to L at 1. So if that's a vertical line, let me just double check it is vertical. Yep. So we're going to travel through there, 90 degrees. Quite a bit in this axial symmetry question. A lot of points there. Okay, so get our compass. First of all, we've got from here to here, so an arc. So that's 1 point. And our second one there. We'll move down. We've got a small little distance here in our compass. We have to be as accurate as we can. There we go. Down to our next one. So we need that distance. Other side of that rectangle. And finally, the distance out here to that corner or to an inclined line. So down along, we've got this distance here. Okay, we've the other side of that little rectangle. And finally, we have 2 points down the base. 1 and 2. Okay, so typically I would label all the points. You can do it if you need to, but I think it's pretty straightforward. This one will follow everything around. So I've got my little rectangle first. There to there. Okay, we've got our line traveling out. And it travels back to here. At the base of it. Back up here diagonally. Back in. Okay, and finally we have the top. We have the 2 points down below them, but it should be vertically down. Yeah. So a nice, neat axial symmetry there. So it's binoculars really, so we have half a set of binoculars. Right, so that's part A. Part B, the image across shows a glamping pod. Design includes a parabola DOC. So DOC. So we're going to have a parabola there with O as the vertex. So O is our vertex. That's the important part. Okay. Draw the parabola DOC and the rectangle ABCD. So we've got, in the rectangle ABCD, and complete the elevation of the pod to include a door. So we need to find our door there also. Which will be fine. So most of the marks here are going to be for drawing our parabola. So what we want to do is we're going to divide this side into equal parts. So I'll just draw a line here. And we're going to divide this side into the same number of equal parts. So if I divide it into 4 on on one side, I divide it into 4 on the other, or 5. So for simplicity, let's go with 4 on each. So step off 4 distances, all the same. So 1, 2, 3, 4. I always like to number 1, 2, 3, 4, just to make sure I've done it correctly. And my important line is the line joining from that 4th back to A. Okay. Now I'm going to use sliding set squares to draw my parallel lines. Parallel from 3, 2, and 1. Okay, now I'm going to divide this into 4 equal parts. So 4 equal parts again, so we'll go 1, 2, 3, 4. And those 1, 2, 3, 4, just to make sure. Join the end of those divisions back to the end of the line I'm trying to divide up. And then we're using sliding set squares. Great. So we've divided our one side of our rectangle up into equal parts, the same number of equal parts. Okay, so the side that contains the vertex, we're going to have those divisions coming straight down, parallel to our axis. Okay, now here's the mistake people make. They draw a line straight across here also. No, we want to join these ones up to the vertex. Okay, so now we've got 1 and 1 is a point, 2 and 2 is a point, 3 and 3 is a point. So that's half of our parabola. Okay, now we want to find the other half. You could do a whole construction again, or because this is an axis, we can use axial symmetry, same as what we did above. So we're being kind of examining the same thing for half of this question. So through the axis at 90 degrees, and then whatever distance I have on one side of the axis, I mirror that across to the opposite side. Next point down, that distance mirrored across to the opposite side. Next point down, increase the distance there, that distance mirrored across to the opposite side. Okay, so I've got 3 more points, 1, 2, 3, and my freehand curve like so. Alright, so there's my parabola drawn. And to finish this off then, we need to draw our door. So the base of my door is in 25. And the axis there, so I'm going to be in 25 from both sides. 25, in 25. I'll draw vertically up here now onto my parabola. Vertically up onto my parabola. Top of the door then. And don't forget the line down the middle of the door, because it's a double door. And our base DC. Okay, so that is my parabola. All right, next up is part C. So the image shows a mallet for driving tent pegs. Okay, so for banging the pegs into the ground to hold down our tent. Shown below is the outline of a similar mallet and a tent peg. So here's our mallet and our tent peg. Redraw the mallet below, rotated anti-clockwise, so clockwise, anti-clockwise, about point O. So O is our center of rotation, until A reaches the line L, L1. So until A hits our peg down there. Okay, so I'm going to start labeling a few points here. We've got A, B, C, D, we've got E, and F there as well. So first thing we need to do is rotate all of those points. Okay, so O is my center of rotation. I'm going to rotate A down until it hits the peg. So that's the path that A follows. B, actually, you know what? A, actually it won't be in line with B, no, sorry, up to B. So B is following that path, we don't know where it ends. C, very close to B, but just there. We don't know where it ends. And then back to D. It's there. We don't know where it ends either. And we got E and F. Kind of hard to distinguish between the two of those. They're nearly on top of A as well. Okay, so we'll deal with those in a minute. So A is rotated down, it's hitting the mallet at there, which is A1. So that's our position for A. Okay, as this mallet rotates down, its shape isn't going to change. So the distance from A to B will stay the same. So I'm going to get the distance from A to B. Actually, A to D we'll start with. So A to D. Swinging arc there, we can see D is traveling down, and here is my D1. So that's that part of the mallet, the base of my mallet. Okay. Now the reason I didn't do D or A to B first is, imagine if I'm swinging that arc. Okay, it's going to be very hard to see exactly where it crosses. So I found a point where I knew the arc would cross the other arc, okay, because it's a kind of easier view of it. So now I'm going to go A to C. A to C. So now I have C coming down, and there is my C1. Okay, I'm going to go D to B, because that should then cross that arc nicely. So D to B, or crossing the arc nicely there. B1. Let's draw my mallet. Okay, so there's my mallet. Now redraw the mallet below. So we need to have these also rotating. So points F to A will be the same distance. So I'm going to go F to there. F to E will be the same, but I know that DE will be the same distance. So I'm actually just finding these on the line that we currently have by swinging arc. So there, that's F1, that's E1. I know F is joining back to O. So we're on the right track. Okay. It's going to be very hard to rotate that point, but we'll do our best. We'll call that A, B, C, D, E, F, G. So G, we're trying to rotate that up a little bit. There. Okay, and we know the distance from E to G would be the same. So here's E down to G. So E to G. And now I've got G1. And finish all of that off. Okay, so there I have my mallet redrawn. Okay, so part C completed. Okay, part D, the image across shows a tent. So we've got a tent here. Shown below is the plan, an elevation, an incomplete end elevation of a similar tent. So we haven't completed it there. Complete the end elevation. So we have our depth projected up. So what we need is our heights. So AE is projected, BD, project that across, and C, project that across. And let's go up then with my depth. It's the same width all the way, straight up, straight up. And we'll put in those edges heavy. Okay, so my end view, looking in, I'm happy with that. Complete the indexing of the end view from the given elevation and plan. So we have all these labels A, B, C, D, E, and they're at the front surface. So we're looking in this direction for my end view. So we're going to see A, B, C, D all on this edge. So they're traveling up to here. So A is here. E is also going to be here. Because we're standing here and we're looking in, we see A first, then E. So we always label A, comma, E. The letter we see first, and then the letter we see later. Okay. Next up, we're looking in, we see B, B, and then D after it. So B and D after it. So B, comma, D, and then finally C is on its own up the top. So that's my labeling or indexing completed as well. All right, on to our final question of the 2025 paper. So this was an ellipse question, a little bit tricky, the way they've set it up, and a little bit to do with this tangent. So let's do what we can, and we'll talk again. So shown on the right is a dimensioned drawing of the logo for a campsite. It's kind of a caravan. The curve ABCD is a semi-ellipse. So ABC is a semi-ellipse. So that is a semi-ellipse, half an ellipse. OB is half the minor axis. So OB is half the minor. Full minor would be all the way down. F1 and F2 are focal points. So F1 and F2 are focal points. And DP is a tangent to the ellipse from point D. So it's a tangent to the ellipse from point D. So that's a tangent. QRS is an arc. QRS is an arc. That's fine. We don't have the center of that arc, which is another interesting thing. So, part one. The length, we could get bogged down on everything that's going on there. Let's just go step by step through it, see what we can do, see what they're asking us first. The length of half the minor axis OB and the focal points F1 and F2 and the position of the major axis, here's the position of the major axis, are given. Find the length of the major axis and draw the semi-ellipse. So we need to find the length of the major axis. So that's like working in reverse. Usually we have the ellipse, we're trying to find the focal points. Now we've got the focal points and we're trying to find the ellipse, okay, or the major axis. So the distance from here to here, it's what we usually do, is swing that distance, and that's my minor or my major. So I'm going to get the distance from B to F1, that distance there, point of the compass down, and here we have my major axis. Okay, now they're going to ask us to draw the semi-ellipse, so I'm going to draw my major circle, or major semicircle, because it's a semi-ellipse we're drawing. Right, and now we'll continue on, we'll draw our semi-ellipse. This should be easy for you. Okay, it's something that's asked every year of the course so far. So there's my semi-minor axis. Now we want to divide that up 60-30, so 60-30 degree set square, split that, 60 degrees, 5 degrees. Okay, so now we want to find our points. So where our major axis is cut, our major circle is cut, we draw towards the major axis. So everywhere our major axis is cut, we're going to draw towards, everywhere the major circle is cut here, we draw down towards the major axis. So down, down there. Okay, and now where the minor circle is cut, we're going to draw out towards that line that we've just drawn. Okay, so that's given us points 1, 2, 3, 4, 5, 6, 7. Right, so I'll draw my ellipse. Now I'm not going to draw this little portion heavy because I'm not going to need it heavy, so I'll draw maybe as far as here. Pretty heavy, maybe just around there. So nice gradual curve, looking at the point you're traveling to, not at the point of your pencil. Okay, I'll just draw this lightly then. Okay, so there's the outline of my semi-ellipse. Part 1 completed. Locate the center of arc QRS and draw the arc. Okay, so here we have this arc. Okay, it's 15 out, so we should be able to find, we should be able to find all of those points, and we're going to be asked to find the center. So let's find all of those points first. So straight down from A, that's my A there. Here's my C. So straight down, I've got some measurements. Okay, I'll mark off some of these measurements. So we've got 75 total. So 10, 25. So 10, 25. We've got 20 and 20. 20, 20. Okay, so we've got Q, we've got S, R is going to be out here, a distance of 15. There's R. Okay, so we are looking for the center of this arc. Okay, so this actually harps back to the first question 1. Okay, we are trying to find the center of an arc or center of a circle. So how we do that is we join up these, they are chords, and we bisect to find a line running through the center. And we repeat that again. Where those two bisecting arcs or two bisecting lines are found, then we can draw a circle. So here's our chord QR, and here's another chord RS. Okay, so let's bisect these now. So any distance set to more than half, swing an arc, swing an arc. Same here again, swing an arc, and swing an arc. So I've got 2 perpendicular bisectors through my chords, 1 and 2. Okay, where they cross, that is the center of my arc. So I'll just mark that in so you can see it. So that is the center of the arc QRS. So I can get my compass and I can draw that arc with my radius from the center to R. There's my arc. Great, so that's part 2 completed. Now, using the dimensions given, complete the drawing of the logo. So we'll start with some of the easy stuff. Okay, got that side, A down to S. C, I'll drop that down. So that's the outline of my caravan. I'll mark up my doors. And windows and a wheel. So we've got 40 plus 10 plus 40. That's that point there. We'll need that in a while. Okay. And I'm after finding point G, which I'll need in a while too. Righto. So we've got that measurement down 10, we've got Q, that's the distance coming across, and we've got the center coming down here. Okay, so that's just drawing all those light lines just to give us a starting point. So start with my door. The door is going straight up to C, straight up to the line, in the line with C. We'll do this little diagonal X. And now we have the width of that window. So we have the width of that window. We'll drop that down and drop that down. There's my little window on my door. Okay, we got these 2 windows. They're in line with F1 and F2. And they're in line with the wheel. Okay, so we'll have to do the wheel first of all. Okay, so my wheel, we've got a variety of radiuses. Radius 25, radius 20, radius 15. So compass, set it to radius 25 to begin with. Here's my outline, so just space for my wheels to go in. All right, radius 20, and that's going to be a full circle. And radius 15 will also be a full circle, and that's my wheel completed. All right. Okay, now back to my windows. So the width of the windows is from F1 and F2 down, and then the width of the wheel. So from there to there, and F2 down. And width of my wheel, project it up. There we have it. And from F1 down. Okay, and tops and bottoms of those windows. So these are easy marks to pick up. We're just reading a drawing, reading the measurements and following along those light lines. We've got the base. base. Draw that in heavy. And we've got that straight line going up to D. Okay. We have a 25-degree angle, so this is the first time we've really had to use our protractor in this exam. So 25, so make sure we go to 0 and count up. 25. And it's heavy just there. That's my 25-degree angle. Okay. So you notice that I've left this line PD until the end, okay? Because this is probably the most challenging part of the entire exam, okay? They asked you something that hadn't been asked in the past, okay? It's something that's a nice little, I suppose, tester to see are you studying your graphics or not. So we have learned about, you would have learned about tangents to an ellipse given the point P, but here you have not been given the point P. We don't know where it is. But they have given us this point D, so we have point D. So this construction, okay, is we're going to get we're going to get the full major axis. So this full major axis from A to C, right? Our full major axis, okay? And we're going to swing that from F1 here. Yeah, from F1. So swing that arc there. Okay, so that's my major axis. Now I'm going to get the distance from D to this focal point, the near focal point. And I'm going to swing that up. Okay, so that finds me where those two arcs cross each other. Okay, and what I'm going to do then is going to join that back to my focal point F1, to the further away focal point. Okay, and where that line then crosses, that's going to be point P. Okay, so once again, major axis, the full major axis, okay, and I swing that from F1. I get the distance from D to F, the opposite, up to the closer F, swing that arc, and here we have that point. And then from D, I can join that back, and you can see there it's tangential. So D back to point P. And now I'll just go over that portion that I haven't put in heavy. Very last thing on that exam, probably the trickiest part of the exam. Only would have been a couple of marks going for it, even if you found it difficult. So that's the 2025 paper completed.